Guess we're going. Today's topic, evaluating functions. Oops, can turn that thing on. There we go. I have control. Great. So, evaluating functions in our functions unit. This graphic should look familiar. It's the one that we've seen before, evaluating functions. So basically a function, something happens inside the box. We put something in, we get something out, and we remember that what we want is we want it to be a predictable sort of thing. So the key word that I like to use with a function is that it is predictable. I'm spelling predictable, right? Looks okay. So I'll show you how to evaluate a function. Here's my function. You might recognize it from the other day. The f of x equals 3x plus 4. So what's going on inside my box is I'm going to take whatever number it is, I'm going to multiply it by 3, and then I'm going to add 4 to it. Okay? This notation means what happens when I put a 3 in. So when you see the f of 3, it means what happens when 3 goes in the box. In. So what comes out when 3 goes in? So remember, in, out. So inside the box, we're doing 3x plus 4. So the f of 3 is just 3 times 3 plus 4. And then we use our order of operations stuff from the very first part of the class. 3 times 3 is 9. And then we have 9 plus 4. And then we do the addition. 9 plus 4 is 13, I think, right? Yes. Okay. The f of 7, no different. 3 times 7 plus 4. Just plugging in whatever number is in the box right here goes into the x value right there. So 3 times 7, 21 plus 4, and so the f of 7 is 25. And we'll do one more with this. The f of negative 4, still same story. Going to plug negative 4 in for x plus 4. 3 times negative 4 is negative 12. Plus 4, so where this might get tricky is adding the negative 12 plus the 4. Negative 12 plus 4 is 8. Okay? And that's it, evaluating functions. So then we have something like this. Okay? G of x squared minus 4. Just a different function, but same thing. We're just going to plug the number in. I think I will do this second one, and I'll leave the inside and the outside ones for you to do. Now, if we're doing the g of negative 2, we're just going to plug in negative 2 squared minus 4. And here's where we want to be careful. Negative 2 squared means negative 2 times negative 2, which a negative times a negative is a positive, so we end up with 4 minus 4, which is 0. Okay? You do the g of 5 and the g of 11, and we'll check those answers tomorrow just to make it a little faster for us. But it shouldn't be a big problem at all. Plug the number in for x and evaluate. So it's just solving functions. We're going to move on to domain and range, which are two particular pieces that are specific to a function. Didn't take long for that to happen. The domain, pen back, the domain is my input. The range is my output. Okay, what value goes into the machine, what value comes out of the machine. A lot of times we think of the domain as my x values. And the range as my y values. Okay? Input, output, x, y, domain, range. What I want to point out to you is the alphabet. So the way to keep track of which one's domain, which one's range, it's alphabetical order. D comes before R. X comes before Y. Input comes before output in the alphabet. So it's an alphabetical order. Bear that in mind. So the possible x values, the possible y values, the input versus the output. That's what the domain is. Okay, domain, input, x, range, output, y. Alphabetical order. Alphabetical order. If that helps you to remember, great. Domain comes before range. I think I've said that before. Let's move forward. Shall we? Great. So we're looking at the domain and the range of this particular function right here. And first of all, I guess I probably should say, is it a function? I think it is because it's one that we've looked at before. It's the 1, 2, 3, 5, 6, 1, 8, 23 function. So the domain, as we previously said, domain is the x values. So my x values are 1, 3, 6, and 8. Okay? The range, that's my y values. So my range is 2, 5, 1, and 23. You can put them in order if you like. I don't feel that it makes much difference because we're not necessarily worried about having the, matching them back up or anything like that. So we might write that as 1, 2, 5, 23. That'd be fine, I think, as well. Okay? Domain, x values. Range, y values. So when we see ordered pair, that's easy. In the table, got some x values, got some y values. What's the domain? What's the range? Domain, 0, 2, 5, 8. Range, -6, 3, 8, 25. Hey, those are in order. That's nice. Okay, x values, domain. Y values, range. Alphabet plural. I don't know if I mentioned that. All right, so then we get into if we have like a function and function notation and we want to find the domain and the range. So what we're looking for in a lot of these problems is we're saying, well, what possibly happens with this? What possible x values can I put into this function? So I don't know, is there any, and to a large extent we look at, are there numbers that we can't put into a function for some reason, or are there numbers that we can't get out? So in this case, there's no number that I can think of that I can't put in this function. I can put anything in, positive numbers, negative numbers, fractions, decimals, whatever I want to put in there. So we list out our domain as all real numbers and look back at our number and operations work from the first day, just if you're not sure what the real numbers are. So all real numbers is what our domain is. And to a large extent, if I can put everything into the function, I pretty much can get everything out of it, particularly in this case, all real numbers. Oh, that skips, but there you are. So that's pretty basic. All real numbers, that's a fairly common domain as we move forward. I guess that's about all I have to worry about. I think for now, yeah, we'll get maybe a little deeper in some of the functions ones, but we're just trying to get the idea of what's domain, what's the range. If I had to ask you what's the domain and what's the range, hopefully you'd say x values, y values, x values, y values, input, output, that sort of thing. So evaluating functions just takes in the order of operation stuff that we've done in the past, and domain and range, remember the alphabet. That's about it, I think. So this was a relatively short little operation today. See if we can get the clock back. 7 minutes, 47 seconds. Excellent. So thank you for watching. Hope you learned something. Talk to you real soon. Bye.